Hello, my name is Pachayathon, Project Manager, Renewable Energy, and for this session, I will provide you the brief overview about solar floating, starting with the key factor that drive the solar floating market. Then the next one will be some key consideration you should take into account to start the project, such as site assessment, technical assessment, environmental impact, and permit assessment. And the last one will be example of our case study. And let's start to the next slide. Recently, solar floating continue growing in many countries, and here are some key factors that drive the market growth. Number one is about limitation of available land and roof area for building solar projects. The second one is decreasing trend of the system capex. It is driven by the lower cost of the pontoon. And the next one is about the cooling effect benefit from install the PV on the water, because by theory, PV will perform better if the temperature is lower. Then the next one is a big benefits. It's about increasing the water surface utilization, such as artificial or natural reservoir or even open sea. And you can see the example of the floating project in the pictures below. In the next few slides, I will provide you example of consideration factors when start solar floating project. The first one is the site assessment, which have four main parameters to be taken into account. Start with water level. The water depth variation shall be verified whether it's suitable for the system or not. If the variation is too large, it can have an impact on technical part. Same as wind load, which affect project safety design. The recent example of wind load effect, if everyone remember the accident case in Japan 2019, where the solar floating was damaged by the typhoon. Seasonal change in has better location like Northern or Central Europe also shall be considered, because let's say if the water turn into ice, it may affect the floating arrangement, because the solid of the ice can pack up the array of the pontoon. Bathymetry and soil characteristic also is a play important role in the site assessment, because the different bathymetry and soil characteristic can affect the anchoring design, and it may add the project cost differently. For technical assessment, you have to carefully evaluate floating system technology, because everything starts from here. Let's start with the floating pontoon design and material. This is because one supplier design may provide the flexibility of the number of PV panel per string, while another supplier is fixed. Or one design, let's say, may need a crane for the pontoon assembly, but another is not. Or when talking about material, one supplier may provide pontoon with the HDPE material only, but others may provide the pontoon system, the floating system with the combine of steel and the HDPE. All of this will affect your cable arrangement, design, and losses, your construction method, and durability of the project in long term. That's why it's very important. Anchoring system also important, same as the design and material. In general, the anchoring system we have two design. The first one called onshore anchoring, and the second one is bottom anchoring. The onshore anchoring is mean you just ram a pile and then carry out a sling to the floating system to make it stable. For the bottom bank, you dumped the concrete block to the bottom of the water pond to make the floating stable also. But these two methods affect your project cost and the construction method differently. And to select which one is suitable for your project is depend on your site specific, like water depth, the distance from the shore. And another factor that we see is very important also, but many people most likely to forget when they start the project, is to check that your PV panel size and support pontoon size is matching. This is because we has a previous experience before that the PV pre-selected model at that time is the size is increased a little bit, but the pontoon support cannot handle that increasing because the dimension is fixed. So uh, the the new selection has to perform. Apart from the technology is the plan layout design. I will narrow down and specifically to the walkway because for the some pontoon supplier they have a range of option for you to select, like 4 PV per one walkway, 2 PV string per one walkway, or 1 PV string per one walkway. So you have to balance between the project cost and easiness of O&M service activities. And the last one for technical assessment is about operation and maintenance service. For example, if you have the project with the string inverter types, you have a choice to put the inverter onshore or put inverter offshore. If you put the inverter onshore, it will be easier for O&M personnel to separate the system when they have any emergency accident, but you have to trade off with the cable losses. However, to put the inverter offshore, you save the cable length, but think about how difficult when people need to separate DC and AC system. So all of this is about to find the optimum point on your project. And this slide shows you the permitting and environmental impact you should take into account when evaluate your project. The first one is about the standard and local regulation that apply to the solar floating may not in place in many country or the market, like solar farm or solar rooftop. So it may difficult to write down the scope or communicate with your contractor how to control the quality of the project and comply with the regulation. Then if your project is located on the open reservoir like a river or a natural pond, the complicated permitting process to build the project may occur, and it may affect the project feasibility. Then we face the experience before in some country that the the local regulation they specify the cover area ratio between the PV array and the total water surface area, and you have to take this into account because it may affect your project capacity. And if your PV array is cover most area of the pond in the country or the market that very strict to environmental impact, may request you to make a study report about the effect on marine life. And here is a case study in Thailand, and we will see on this slide how all parameters and the assessment we have gone through in the 2-3 previous slide applies to the real project. The challenges on the project are the site location is close to the river, which you can see on the bottom right. And the local regulation specify the cover area ratio of the water surface not to exceed like 50 to 70%. And the next one, the challenge is project owner required to use two different floating design for their own technical assessment. And of course, they also focus on the project budget. The solution provided to solve that challenge, let's start with the site close to the river, meaning that we have to perform the historical flooding study to ensure that the site will save from the flooding. And for the cover area ratio, if you see on the picture here, actually the pond, just one pond, either the area 1 or area 2 can cover all 3 megawatt. But because we have this local regulation of the cover area ratio, that's why we have to decide and split the project in 2 ponds. And when we split the project in 2 ponds, we have to think about which pond to install in which floating system, because client want to have 2 different system. If you consider the assembly area of the pond number 1 and number 2, at the area number 1, there are much more large assembly area, and we have to select the floating system that require the crane assembly into the area 1, because the area number 2, the crane access is not possible. And to solve the project budget concern, we have to find the optimum design of the system. On the figure 5, this is an example of the floating design number 2. So the supplier provide you the option to select walkway, how many PV string per walkway, 4 in a row, 2 in a row, 1 in a row. But to balance between the project budget and the services, in this project, the project owner select 2 in a row. And yes, I hope everyone can have a better brief and understanding about solar floating. Thank you very much.